So, hello. So, in this video, what we are going to see is the image classification using VGG system. So, a deep learning. Okay. So, I'm using this Google dataset. Okay. So, pneumonia dataset. You just click it, redirect to the link. So, the dataset link. Okay. Then, the table of contents. So, what are the steps we are doing? So, first we analyze the data. Then we balance the data, then the data pre-processing, train the model, result. Okay, you just have to click the result, it redirect to the results. Okay, so in the first cell we import what are the required libraries we need. Okay, so we import what are all the libraries we need. Then the data analysis. Here we using pandas library, we save the path and their labels. Okay, so we see the pandas labels and we count. So we count the labels. So as you can see here, so pneumonia has more than 3000 images, and normal it only have a couple of thousand images. Okay, so this is the graph. So the pneumonia is higher. So there is an imbalance in the data set. Okay, so using data undersampling, so we reduce the pneumonia dataset and give a equal data. So both normal and pneumonia. So this is the code for we undersampling the pneumonia and balance the data. Okay. So here the visualization of the dataset. So currently we have a balanced data. Then let's we go for pre-processing, data pre-processing. So in the beforehand, we did with the path of the images. Then we here we using the CV, OpenCV, okay, OpenCV library. So using IMDIT, we read all the data. So both for training and testing. So the dataset separate. Uh, the dataset we have taken, it have a separate folder of train and test folder. Okay, so there is no need for we split the data. So this is the shape of the data, and we using the unique to find out the number of classes we have. So here we have two classes. One is normal and pneumonias. Then we using label encoders. We change that normal pneumonia. So it's in a string format. We using the label encoder to give the numerical values, like example 0, 1. Okay. Uh, then we give an appropriate name to the train and test data. So X train, Y train. Then we normalize the data. Okay? So normalize the data. Then here with VGG some architecture. So this is the image. Here, so in the TensorFlow, that already have a pre-trained VGG architecture. Okay, so instead of we write the whole VGG, so we take that library VGG system from TensorFlow, we use the printed data and give a trained model equals to false. Okay, so the trained model it have a thousand classes. So we didn't need a thousand classes. We only need the architecture. We train the model with the our new classes. Okay, so that's why we're giving layer dot trainable equal to false. So then we give our classification layer. And then so dense and we give the number of classes. The activation is softmax. Okay. So the next step we give the compiler to the optimizer, the loss functions, and we train the model. Okay. So using model output, we train the model. So we have 10 epochs and we have a accuracy. I think it's 50. So we didn't use any enhancement. So maybe in the next video we use some optimizers like the generic algorithm, like okay, so the biometric algorithm. So we use some enhancement to so we optimize the accuracy. This is the plot. So then we save the model. So already it have a model, okay, and this is the results. So I have a scikit-learns using confusion matrix, their classification, their precision, recall accuracy, okay, and their predicted images. We select some random images and it should be predicted correctly. So we have to save the model, okay. So here is a web application. So using web application, we can also find. So here I list some. So you just click open and submit. It predict the image. Okay. So this is a web application. I'm using Flask to develop that web applications. So okay. So see you in the next video. Thank you.